Awesome. Thank you, guys. So I'll give a little bit of an intro before starting. I haven't done a lot of big Zoom meetings, so should I guess I'll share my screen once we get started. But as Ginny and Rachel mentioned, graduated 2013, which is 4 years ago now, which is crazy because I feel like it was just yesterday. Started as an economics concentrator and kind of turned to stat after 110, realized it was a way better path for me. Ended up taking a bunch of stat classes, as they mentioned, taught a bunch as well. So 110, 111, 104, and 171. So have been through, these courses multiple times, and hopefully we'll be able to give you some insight. I'm wearing my Greeno shirt, as hopefully, I don't know if there's probably some Union Dorm people on the call, but okay, perfect there. Yeah, spotlight. Awesome. So I took 111 in the spring of 2015, and I'm just going to start by giving kind of a high-level anecdote of my experience. I remember it was like week 1 or 2. It was the first P set, and it was the first one that had to do anything with R. And it was my first, like many of you on this call, I know we kind of polled to see people how much experience they've had with R and with coding before. This was my first experience ever with any sort of coding, any sort of programming language. And I remember for the first P set, just sitting in the stats department on the 7th floor of the Science Center, and just had to plot something super simple. And me and my P set buddy just had no idea how to do it. And we were just trying random lines of code. We have a friend who's like, oh, try this line of code. We just paste it in and it would totally fail. And we were basically just throwing darts and just hoping that the code we put in that we weren't understanding would work and would run and would get us what we wanted. And looking back now after all these years, the lesson I learned, which is something that's applicable to many of you, is that just take the time to really understand the basic stuff, the fundamentals, and it will help you a ton in all the kind of R stuff that you do, because it's really not worth it just to kind of throw stuff at the wall and hope that something sticks. Take your time, understand the basics, and it'll really carry you far. And for a lot of you, I know people taking 111, it's a lot of spring semester sophomores. I took 111 my spring semester, and then I took CS50 my junior fall. And just having the R experience in 111 helps so much with CS50, helps so much with all my other coding classes. So just take this opportunity to learn about programming languages, and it'll help you in the future. So without further ado, I'm going to share my screen. So hopefully everybody can see. Just give me a thumbs up if you guys can see the screen. I want to make sure I did that right. Awesome. Cool. So what I've navigated to here is my R Studio session. I know Ginny and Rachel mentioned that they had kind of a session on how to install R before this, so I'm not going to be talking too much about that. It is one of the most annoying parts about R. It's just getting it on a computer. But honestly, if you're having trouble with that, reach out for sort of a separate discussion. But I usually just Google install R, and I put it on my computer. So one thing first to note is that, I remember looking at something like this for the first time and just being like, oh my God, what's going on? It looks like you're in the Matrix. There's different panels, different things. And don't worry, just take your time. Eventually you'll feel more comfortable. We're going to start going through and kind of working with what this actually is, and hopefully things will make sense. Specifically, what I'm in now is something called R Studio. So R is the programming language, Python is a programming language, C++ is a programming language. R is a programming language, and R Studio is the interface, the GUI that you actually use to run your R code. You can run just straight R code from your computer, but it's usually going to be more challenging, and this just kind of gives you a nice way to package it all together in a very easily understandable app. So I'm just going to quickly go over what we're seeing here. On the left, this is our script editor. So basically files of code in R are called scripts. This is where you put all your code. You type out the code here. You can save it. You can, just like any other files, you can see here I have a bunch of files. You can navigate to different files. You can close your file, open other files. And this just allows you to type a lot of code and save it, to run for future use. And then on the right, we have where the code is actually run, console. Okay, and you're gonna write your code in this on the left in this script editor, and you're gonna run it on the console on the right. There's two other panels on the bottom here. This is this panel on the bottom left is kind of a catch-all panel. It, gives you everything in your history, everything that you've run. It shows you what's in your environment, so what variables you've already saved, but we're not really going to focus on today. And then the bottom right is mostly used for plots, like viewing plots, which we'll get to at the end of the session. So for now, we're just going to talk about the script editor and the console. And I should note, feel free to interrupt me at any time if you guys have questions. It's a relatively small group, so we can definitely try to work in some questions if they come up. And if you're having a question, someone else probably is too. So I think number one to start with R is that you can think of it as basically a calculator. That's how I kind of like to think about it at the beginning, help me get comfortable. You can go into the console, so you see my cursors on the console here, and you can type 4 plus 4 and hit enter, and it will give you the right value of 8, right? You can type 9 divided by 3, and it will tell you 3. So obviously, R is very powerful, and we're going to use it for a lot more than a calculator, but at its base, it's basically just a very strong calculator that you can use to do a lot of different things, kind of like Excel. I'm sure everyone here is familiar with Excel. You can use Excel as a calculator, but you can use it for many different things, and that's what we're going to be working on today. So we'll go back to the script editor where I've kind of put some code in. I'm going to walk through kind of each part and kind of what it means, how it can help you overall with R. So this first line over here, I've typed, this is a comment, and you can see I've got this little hashtag at the beginning of the comment. You can also see that it's in blue, whereas some of the other stuff is in white and red. So what happens when I run this, and you're not going to see it on my keyboard, but I'm hitting Control and Return. That actually is not what I wanted. One sec. Okay, what happens when I run this? So I'll just copy it and paste it to the console. So I copy and pasted the code into the console, and I ran it, and nothing happened. And that's because R knows that when you put a sort of hashtag at the beginning of your code, it's not going to run it. This is just for human eyes, right? It's not for the computer. The computer's not going to do anything with it. The whole idea here is that it's important to comment your code so that you going back, reading it later, or someone else reading your code kind of knows what it's doing. So you'll see throughout this code, I have comments kind of describing what the code is doing, what I'm thinking, and the computer won't run it and won't do anything with it. Okay, so that's block one. The second block, I'm going to highlight it, and you can't see my keyboard, but I'm pressing Control and Enter. And you can see when I press Control and Enter on the right, that code runs in the console. So we have this first line. Again, this is a comment, so it didn't do anything. It just tells the human that we're doing some arithmetic, and then the arithmetic that we do is 4 plus 4 is 8. So again, this is just an example of R kind of being a calculator. Awesome. So that's R at its most basic. We'll take it up a step. One thing that you can do in R, and something that obviously is going to be super important, is saving variables. Okay, so if I run this line, right, and again, here I have my comment that's telling me what I'm doing, I'm saving a variable. If I run this line, so I'm going to hit Control Enter, you see it ran in my console. The value 5 is going to be stored in the value X, okay? And then if I just go and I run X now, and I print it to the console, you're going to see that R knows that 5 is stored in the value X, okay? And that's really nice because if I want to do X divided by 2, I'm going to get obviously 5 divided by 2, which is 2.5. So there's one kind of interesting thing to note here, and that is this little operator here, okay? You might be expecting to see an equal sign, like why wouldn't I just say 5, X equals 5? Instead we see kind of this value. Does anyone want to guess why we have this like little operator instead of an equal sign? Okay, that's okay. Oh, sorry, someone raising their hand. I'm super bad with Zoom. I see like a couple of hand emojis, but I'm not sure what that means.
Oh, I'm raising my hand. Is it because it'll
okay, yeah, go
like equations? Like if you put something blah 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 equals that, it'll tell you what the variable is.
Yeah. I think you're on the right. Yeah, I think you're on the right track for sure. So there's a couple of reasons. One we'll get to later, which is that the equal sign is usually used for different things, whereas this operator is used for assignment. So that's one reason. The other reason, and this is kind of silly, but you'd be surprised how effective it is. This tells you, it looks like an arrow, right? And it tells you that the value 5 is going into the value X. And I know that seems dumb because it's pretty easy to remember, like, 5 going into the value X, 5 X equals 5. But you'd be surprised when you have a ton of lines of code and maybe instead of having like, instead of having like this value X and a number, maybe you have something like X equals Y or something like that, like another variable. And when you're scanning a ton of lines of code, it's very easy to forget the direction of assignment, right? Like, are you putting X into Y or are you putting Y into X? So this little assignment thing, it just takes care of it. It seems silly, but you'd be surprised how many like silly errors are saved because of that. So that is saving variables. If you have any questions, again, jump in, just unmute yourself and interrupt me. The next kind of thing we're going to talk about is once we have saved a variable, we can concatenate them. And concatenating is just a big word for kind of combining variables, putting them together. So for example, in this previous case, I just assigned the value X, the value 5 to X. In this case, I'm going to assign the value 3 and 6 to Y, okay? And I do that with this little C thing. The C stands for concatenate. It's such a common function in which we're going to talk about, such a common function in R that we don't have to, it's not called concatenate, it's not called concat, it's just C because it's so, popularly used. So if I run this line of code, you're going to see it ran in my console and I print out Y. You're going to see that Y is this object, it's a vector that has two values. It has the value 3 and it has the value 6. Okay, so I kind of merged, combined 3 and 6 together, I put it into Y. And let's look at this piece of code. So I have this little Y square brackets 1. Does anyone have a guess as to what's going to happen when I hit enter?
You'll get 3.
Genius, love it. So basically there are two values in Y. There's the first value and the second value. We're indexing into Y. We're looking for the first value, so we're going to get 3. If I said Y is 2, or said the second value of Y, we're going to get 6. And if I tried to index into the third value, I'm going to get this NA, which means not accessible because Y only has 2 values. One thing to note is if anyone's familiar with Python, Python is 0 index, which means you would start with Y index 0 instead of starting at 1. That's not the case in R. You're going to get, not an error, but you're going to basically get a warning message because Y starts at 1, which I think makes more sense than starting at 0. Okay, so the next kind of thing that's really cool, and this is kind of, we're closing out on kind of the introductory stuff, is I've saved this value of X, I've saved the value of 5 into X, and I've saved the values of 3 and 6 into Y. One really cool thing about R is that the operations are vectorized. Okay, so that's basically a fancy word for saying that if I add together X plus Y, right, in this kind of equation, R automatically knows what to do. You might see this as a human and you can immediately, know what this means. I want to add the value 5 to 3, and I want to add the value 5 to 6, and I want to get a vector of length 2. And that's exactly what Y does, right? It does 5 plus 3 is 8, and it does 5 plus 6 is 11. So R is vectorized. This saves a lot of time when it's doing large operations. Obviously, in this case, it's a very small operation, but a very cool part of R, very intuitive part. Okay. And finally, last kind of part for the introduction stuff. Hopefully, everyone's kind of familiar with like if, and, or statements. You might have used them in Excel, but basically R has kind of an internal logic engine. If I type something like this is saying 3 greater than 4. Basically, this is asking R, is 3 greater than 4? And if I run this, I'm going to get false. R says no, 3 is not greater than 4. And you'll see this capital false. Whereas if I run something like 5 greater than 2, I'm going to get true because indeed 5 is greater than 2. So a nice kind of feature with R. If I run this, so I had greater than, we can do less than. If I run this guy, these two equal signs means I'm asking R, is 5 equal to 5? So I run this, is 5 equal to 5, and I get true. And note that before we talked about kind of this operator thing, right? Meaning assignment. The equal sign, usually in R, we use it to see if two things are equal. It's checking if two things are equal. This like arrow thing is for assignment. And that's kind of why we differentiate, because when you're scanning code really fast as a human, you just want to see, like when you see equal signs, it's checking if two things are equal. When you see assignment, it's a different thing. So that's why we kind of have that here. And we can use this sort of logic stuff with if and statements, right? So I have this like if statement here. And you can kind of read it in English. You know, it'll take a little while to get the syntax, but basically the idea is I type if, and you notice R makes it a different color, makes it orange because it knows something's coming. I type in if, and then within the kind of parentheses, I enter the question for R. So it's basically saying, if 3 is greater than 4, then do something within these brackets. So you see I have these parentheses to kind of enclose like the question. And then I have these brackets, and I can even, like, if I want to fancy, I can like collapse kind of what happens. Within these brackets, basically saying do something. And in this case, it's just saying print the word nice to the console. So if I run this, that's not what I want to do. Sorry, I ran everything. Okay, if I run this in the console, I'm going to say if 3 is greater than 4, print nice, and 3 is not greater than 4, so R did nothing, right? It didn't, you know, it didn't work. Whereas if I ran this one, it says if 5 is greater than 2, print high. So I run that, and it indeed will print out high. So that's the idea with these if statements. The last if statement, if 5 is equal to 5, print way to go, and it did in fact do that. You can also kind of, I'll just do one on the fly. You can string together and an if as well. So these two ampersands basically are the and operator. So it's saying if 5 is greater than or equal, if 5 is greater than 2 and 3 is greater than 1, then print high. Both of those are true. So if we run it, we are going to see high. And you can also do or statements. So instead of 2 ampersands, you're going to do these 2 vertical lines here. This means or instead of and. So we're going to say if 5 is greater than 2 or 0 is greater than 1. Obviously 0 is not greater than 1, but 5 is greater than 2. So one of these is true. So when I run this, I'm going to get high in my console. Okay. So that's everything for the intro stuff. Sorry if I'm moving too fast or too slow. We just want to make sure we get kind of a strong basis. Jimmy and Rachel are going to send out all these scripts afterwards too, so people can feel free to play with them themselves. But are there any questions before I move on to functions? Awesome, cool. So, okay, let's move on to, we kind of understand the basics of how R works, kind of what it looks like. Let's move on to actually, doing some things, right? So I'm going to start here. I'm going to save the values 5 and 6. Remember, this C stands for concatenate. Save them to Y. I'm going to print Y in my console, and I see I have a vector of length 2, right? 5 and 6 are my different values. Now I'm going to call 2 functions, and a function is basically a piece of code that does some work for you. You just have to use the function name. It will do some work for you. This function on line 3 in our script editor is called sum. I'm sure everyone can guess what it does. It just sums what you put into it. So the format of using a function is you call the name, you enter what you want in the parentheses. The thing in the parentheses is called the argument of the function. So you put, you're kind of, if you've taken, math classes before, you're probably familiar. You put in the argument. Sometimes you want to, maximize an argument, minimize whatever. In this case, we're just entering the argument into the function. If I run sum of Y over here, I'm going to get 11 because 5 plus 6 is 11. And if I run mean of Y, it's going to give me the average, the mean of the Y values. In this case, that's 5.5. So there's a lot of these really useful, functions that are predefined in R. You have obviously sum and mean are very basic functions, but there's a ton of super useful functions that you can use to do different things. And you're going to come across them, as you continue to work. But there's also the opportunity to find your own function. So if you're going to be doing something where you have a lot of code, you're going to be doing the same thing over and over, you can just define kind of a chunk of code into a function and use that function a bunch instead of rerunning your code at the same time. So I'm going to scroll down my script editor here to line 11. We're going to create our own function for the first time. Very exciting. And let's just walk through the syntax really quick. So this first part is kind of the name of the function. I'm calling this fun underscore double sum. You want your names in R to be very clear, kind of as to what the thing is doing or what it's storing. One convention that I like is I start the name of the function with capital FUN. That way you know it's a function. You don't, like the value X is a number. I know this fun underscore double sum is a function. It just kind of helps you keep things straight. And this name double sum kind of implies what it's doing, right? It's doubling the sum of whatever we input. One thing to note is that R is case sensitive. So if I changed this to a capital D, it would be a different thing than the lowercase d. So it's good practice in R to just have everything be undercase, except in this like capitalized, fun case, because it's a kind of a precursor, but you don't want to start messing with like different capitals, that sort of thing. You're just going to confuse yourself. So generally keep things undercase. So anyways, we define the name of the function, and then we have our nifty operator thing here again. Basically what that's saying is we're assigning something, some part of the code to this name fun double sum. And what we're assigning is a function. And again, notice that we have, just like we saw with if we type if, we're going to get something orange. R knows that when we type function, something's going on. So we type in function, and we are going to use an argument. Remember, we mentioned an argument is the thing you put into the function. We're going to use an argument x. Okay, so this function, fun double sum, is going to take one argument, right? It's going to take the argument in the place of x here. And just like before with our if statement, we're defining a function that's going to do something, and what it's going to do is defined in between these curly brackets. And again, if I want to collapse it, I can just click this button, but it's going to be doing the thing in between the curly brackets. What's it going to be doing? Well, in this case, we're going to take the sum of x. So here, this x is the same x as, the x input in the argument here. So we're going to input x, we're going to take the sum of it, and we're going to multiply by 2, okay? And that is our double sum, right? We sum, we multiply by 2, we get a double sum. And then we use this really nice return operator, notice it's also orange, to tell R that this is what we want the function to spit out, right? So, we spit out 2 times the sum of x. So I'm going to run this code. You can see I ran it over here in the console. It didn't return anything because we're not asking it to. We're just defining the function. If you type the function, you're going to see, right? This is just saying, I'm saying, what is fun double sum? And R is saying, this is fun double sum. It's a function. And if we actually try to use the function, so remember y is a vector 5, 6. Let's try to use fun double sum on y. And we're going to get 22, which is exactly what we want. It's 5 plus 6 is 11 times 2. We get double the sum. So, instead of having to type 2 times the sum of y, right, we can just use our fun double sum and kind of run it. And it's really nice. And again, this is a very simple function, but you can imagine that they can get kind of more complicated. Are there any questions with that, with how we define a function? Awesome. So let's make it a little bit more complicated. Let's talk about a function with multiple arguments. So this function is called fun divide. It's going to be naturally a function that allows us to divide numbers. Again, we have the name, and again, it starts with fun, so we can keep track of this function. Again, we have this assignment operator, this arrow. We have this orange word function that tells us we're actually going to be creating a function. In this case, though, instead of just x, we have 2 arguments, x and y. So when we write this, we're explaining that fun divide takes 2 arguments. We have to put in 2 numbers, and it will return a value based on those 2 numbers. Okay, and again, this the number of arguments is key, obviously, because it kind of tells you what your function can do. So in this case, again, we look to what the function is actually doing in between the curly braces. In this case, we're just returning x divided by y. Okay, so we put in x and y, spit out x divided by y. I'm going to define the function here. You can see it ran on my script editor. Again, if I just run the name of the function itself, R is going to tell me, yeah, you have a function here. It's going to return x divided by y. And if I run it in this case, so I ran fun divide, first input is 6, second input is 3. I'm just going to get 6 divided by 3 equals 2. Awesome, that works, amazing. Now, does anyone want to guess what's going to happen when I run fun divide 6? Yes, I see someone raising your hand, but I don't know how to unmute you, so just go for it.
I think it should give an error because the function expects 2 arguments.
Awesome. You guys are 2 for 2 so far. So function expects 2 arguments, and lo and behold, we get an error in the not fun script. Basically says error in fun divide 6, and the argument is exactly what you said. Argument y is missing, and there's no default. Okay, and this is a little bit, kind of a little bit more advanced thing, but the default of a function, when I'm defining the function, let's say I just enter this y equals 3, right? So this fun divide, I have the same thing, but x and y equals 3. This is saying to take y equals 3 as the default. Okay, so if I define this and then I run fun divide 6, I didn't enter a value for y, but the function has a default value for y, so it will work because I didn't override the default value of y. So, but if I don't give it a default and I don't enter a value for it, it's going to give me an error. So just something to note there, but good work. And then the last example, we've only been doing functions that have like one line and return one thing. I guess they always return one thing, but only have one line. You can have a function that has multiple lines within it. So it doesn't just have to be one line. In this case, I just redefined the dividing function. And I just have two separate lines. So in the first line, I do the division. I assign x divided by y to z, and then I return z. That's okay too. You could theoretically, you could have infinite lines in here, many, usually you will have multiple lines within a function. It doesn't just have to be, a single like return line. That's okay. Cool. So that's functions. Two things that are really useful. First of all, I assume in 111 you're going to be using a lot of 110 stuff. So you're going to be using a lot of random variables sort of functions. All the random variables. One reason that R is really, really good is because it has great built-in stuff for random variables, statistics, all that sort of thing. This R norm function it stands for random normal. So basically allows you to generate random values from normal distribution. And if you type in R, if you type this question mark followed by a function name, so I'm going to do that in the console. If you type that, R is going to give you this awesome little help page. So it'll just pop up. You can see it's labeled the help tab. And this is the documentation for the function. So you can see the title of normal distribution. It's got a description, and it's got our function in here, R norm. And basically, this is telling us that R norm will take 3 arguments. It'll take n, which is the number of observations, the number of actually random values you want to generate from the normal. It will take a mean, and it will take a standard deviation. Note that the mean has a default of 0, and the standard deviation has a default of 1. So you don't have to enter the mean and standard deviation if you don't want to. You can just enter. You do have to enter the number of observations that you want. You don't have to enter a mean and standard deviation. It will default to z, as you guys know, as the standard normal. So we can run. We can run R norm 10. This will generate 10 with a mean of 0 and a standard deviation of 1. And you'll see in the console it just populates. These are just a bunch of random draws. I can change the mean to 7, and it's going to give me these values are obviously higher. They're centered around 7. I could make the standard deviation much bigger, or let's say 30, a huge standard deviation, and you're going to see the values all over the place. So this is very useful for your 110, 111 type stuff. You have functions of the normal, the exponential, son, beta, gamma, everything. So really nice part about R. Awesome. So before we move on to the next section, are there any questions on this stuff?
Could I ask a question real quick?
Yeah.
Sorry, I'm very new to this, but I keep on getting an error when I try to run the fun divide function. And I'm not sure, how do I identify
what does the error say?
It says could not find function fun division.
Yeah, so fun divide is something that we defined in our, so like let's say I tried to run, you're probably seeing this error. Let's say I run fun mat. It's going to say, I assume this is like the error you're seeing. It's not found. Fun divide is something that we defined and where we ran the code ourselves so that R knows, where to look for it. It's not something that's prepackaged in R. It's not one of those functions that's kind of just available when you load up R. You have to actually run the function first, get it to be defined, and then use it. Does that help?
Oh, okay. Yeah. So just to clarify though, when I mentioned fun division, that was just because I renamed it fun division because fun divide didn't work the first time. So I have to run the actual function and then do like the one with the numbers. Does that make sense? What I'm saying?
Yeah, you definitely have to like define, like I'll show you here. You definitely have to define the function.
Okay.
And so there I define fun division. I can check, make sure it's there.
Perfect.
And then you can do the fun division. So that'll work.
Great. Thank you so much.
Good. Yeah. Good question. Anything else before we move on? We're blazing through this, so feel free to stop with questions. Like all good. I know how I also know how kind of annoying it can be to look at like an R screen for a long time. So we're going to take a break in the middle too, but jump in with any questions. Awesome. So good work so far. We're going to be moving to our last section before we take a quick break. This section is loops. So loops are a super important part of sort of all programming. As the name would imply, you're basically going to be looping over something over and over. It allows you to do a whole bunch of different things in 111 and beyond. You're going to be using it a lot for simulations, which we're also going to get to. So let's jump right into it. The first type of loop that we're going to work with, there's two major ones we're going to talk about, is the for loop, for F-O-R. You can see in my comment here, I've defined it as the for F-O-R loop. The for loop allows you to kind of iterate a specific number of times, and I'm going to explain kind of what that means. So first, I'm going to define some parameters. It's always a good idea to kind of define numbers you're going to be using. N, which is going to be my number of observations, as you know, you're kind of familiar with. We're going to say N is 10. So again, this assignment operator, N has a value of 10. I'll just define it here so everyone can see. Boom. And then I'm going to define X, use this rep function. The rep function means repeat or repetitive or something. I'm going to repeat the value 0 N times. Okay, so that's going to be my X value. And as you can see in my console, the X is just the value 0 repeated 10 times. So it basically created a vector that had value 0 in it of length 10. So that's kind of what we're starting out with. Now we can enter our actual for loop. And you'll notice here, I type the word for and it turns orange, just like if, just like return. These are all kind of words that R recognizes because they're used to do special things. So the for indicates that we're entering a for loop. Everything in the parentheses is going to kind of tell you what you need to know with the specific loop. So I think the first thing to know is this value I. I is kind of the index variable that you're going to be changing each time through the loop. What does that mean? You're looping over this loop for every I from 2 to N. Okay, every I. It says in instead of from. I think of from. For every I in 2 to N. And this little sequence, if I do 2 to N, remember N equals 10, it's just going to give me the values 2, 3, 4, 5, 6, all the way up to 10, right? So we're basically saying iterate I from 2, then to 3, then to 4, then to 5, then to 6, all the way up to 10. Okay, and that's kind of what's going to be going on within the loop. Again, we see this like same structure as before, where we kind of define what's going on, and everything that's happening, we actually put in between these like curly little braces. So this is actually the code that's going to be happening. And on every step of the loop, we're going to be saying X, the ith value of X, right? So remember, these square brackets are used to index into X. If I wrote X2, that's the second value of X. The ith value of X is going to equal, so remember this assignment, it's going to equal the X ith minus 1, so the previous value of X, plus a draw from a standard random normal. Okay, so the ith value of X is going to equal the I minus 1 plus a standard normal. It's way easier if I write it like this. Let's just say I equals 2. I'm going to say the second entry in X is going to be the 2 minus 1. So the first value of X, this is the same as X1. The first value of X plus a random normal. The reason we do I, right? The reason we have I instead of a number is because every time through the loop, I is changing. So the first time through the loop, I equals 2. We have the second value of X is, the first value of X plus a random normal. Then the next time through the loop, I equals 3, it updates. So, the third value of X is, this 3 minus 1 is 2, is the second value of X plus a random normal, et cetera, et cetera, et cetera. I'm probably talking too much to make any sense, but let's actually just run this code and let's see what happens. If I print out X, you're going to see that this first value of X is 0. And then from there, each value is the previous value plus a draw from a random normal. Okay, so we started out at 0, we went down to negative 0.77, then up to 0.33, and kind of just bounced all over the place. I do have a question here. Why is this first value 0 and not a random normal?
because I starts from 2 and not 1.
Beautiful, 3 for 3. So we have here in our kind of like discussion of, or like initialization of the for loop, I is going from 2 to n. So I never equals 1, it just goes 2, 3, 4, 5, all the way up to 10. And the reason we don't define it as 1, right? If we define it as 1, what's going to happen?
We'll probably get an error because the 0th index is undefined.
Exactly. So if I try to run this, you're going to see over here, uh-oh, got an error. Replacement has length 0. That's because this value, right? Xi, well, first, I is 1. We're in the first pass of the loop. And if I try to print out Xi minus 1, that's 1 minus 1, that's 0. R is not 0 index, so you're going to get this, not really an error, but it basically means a blank. So that is all exactly right. We're going from 2 to n because if we went from 1 to n, we get a failure because kind of the first value isn't counted for. So good work there. So does everyone kind of understand the concept of a for loop before we come back to it at a later date? Does that make sense? Any confusions? Awesome. So for loop is super important, probably more important than the next loop, but the next loop is also very useful. It's called a while loop. So a for loop, we're doing something for a certain amount of time. A while loop, we're doing while some condition is unsatisfied or some condition is satisfied. You'll see what I mean. So we're going to initialize x as 0. So I'm just going to define x as 0, which is the value 0. And here we have, just like with our for loop, we have while, again, it turns orange, R knows that something is up. And within the parentheses, we're going to set our condition, okay? And the condition is basically telling us how often, we're going to loop until the condition is broken, basically. So the condition here is that the maximum of x has to be less than 10. Okay, so this is going to continue until the biggest value in x, which so far x is just 0. So obviously it's going to pass. Like if I just run this x less than 10, I'm going to get true because the max of x is 0, it's less than 10. So while this condition is true, the loop is going to continue running. Okay, so that's basically how long it will run. And again, within these curly brackets, we actually do the work here. So I have this line of code, the actual work that we're doing. This is a little bit more complicated than what we've seen before. We can break it down. Again, we're going to be reassigning. We're assigning something to the value of x. What we're assigning is we're concatenating two things. So remember, the C basically means we're combining two things together. The first thing is x, so just the vector we started with. And the second thing is this a weird guy. What is? Anyone want to jump in and tell me what a guess for what this is? So this piece of code is going to be taking out the last value of x. Okay, so let's say I'm just going to define, I'm going to go off script here and define x as a vector of 3 in my script. You'll see it has the value 3, 4, 1. If I index into the value 1, I'm going to see 3. If I index into the value 2, I'm going to see 4 because it's the second value of x. The length of x, this is a function that basically tells me how long the vector x is. That value is 3 because obviously x has, is length of 3. So if I do x length of x, I'm going to get the last value. I'm going to get the third value in x, right, which is 1. Okay, so this like length of x length of x thing allows us to get to the last kind of value of x. So here we're saying we concatenate together x and the last value of x plus, and this rx, if I, go in my script editor and I do question mark, what is rx? It is the exponential distribution. So hopefully no one forgot the memorylessness property, which is an old 110 joke. This is just a random draw from an exponential distribution. So basically we add on to x the last value of x plus a random draw from an exponential to get a new value. So it's kind of the same thing as what we were doing up here, but just a different way. Instead of using I, we kind of use this, this different length of x format. So let's say I run this and it's going to run and it's going to finish running and I'm going to print it out. Can anyone tell me why, like what made the code stop running? So remember, it's going to run while this condition is satisfied. Oh yeah, go ahead. Sorry, I see the hand raised.
The last value of x is 12. Well, yeah, the last value of x is 12.2, which is greater than 10. And so that condition would be false.
Exactly right. Exactly right. The maximum of x is 12.2. The condition is checked every time the thing is run. So, you know, at the end of the loop, it checks and it says, okay, maximum value of x is 10. We're done. We're cutting out. Whereas before, the maximum value was less than 10. So, you know, we didn't want to stop. So that's basically how the while loop works. It will go until something happens. You can get yourself into trouble with while loops. So I'm just going to, instead of entering max of x minus 10, I'm going to enter true. True is always true, right? Like if, you know, if I'm in the console and I do 5 greater than 3, that's true. But, you know, true is, you can just also just write true itself. So if I do while true, this thing is just going to run forever. It will never stop because the condition is always true. And I had to hit escape to stop it. And it already ran, you can see how fast R is, it already ran like 12,000 times. And X is just this huge, you know, vector because it never stopped, right? I just put in true as the condition and it'll keep going. So you have to be a little bit careful with while loops. If you don't have the right condition, it'll kind of run forever. So this last bit of code is combining a for loop and a while loop. So how about everybody take a minute to kind of look at what's going on here, and just take a minute to look at what's going on, and then I'll ask some questions as to what this piece of code is doing. And just to remind everyone, n equals 10. All right, so does anyone want to venture a guess as to what these double loops are doing? No worries if not. We can step through it. It's definitely, there's some stuff here that we have not seen before. So first we start off, we define our parameters. Again, n is the value 10, x is 10 zeros in a row. Our first loop is this for loop, so we're going to iterate for the index I from values 2 to n. So from values 2 to 10, 2, 3, 4, 5, 6, blah, blah. Everything we do is going to be inside these curly braces. So yeah, that's it. Excellent. Everything we do is going to be inside those curly braces. So let's just imagine we're the for loop. We're running through our first run. We set I equal to 2. We get into the code. The first thing we see is this while loop. So we have a while loop within a for loop. And we have this condition, which I discussed before. It's while true, right? And true is always true. So this thing would run forever if we didn't stop it. So it's just going to, you know, continue to run unless something happens. So while true. And within the while loop, we're going to generate what I call const, stands for constant. We're going to generate a random normal value. Again, this is from Z, the standard random normal, mean of 0, standard deviation of 1. So I'll generate it just to show. We're going to generate a random normal, and then we're going to enter this if statement. This is all within the while loop. If the constant is greater than 1, right, which has like probability of like 16%. If the constant is greater than 1, we're going to break. And this break means we're going to break out of whatever loop we're in. You can see that break turns orange. R knows what it means. It's a special word. And the break refers to breaking out of this while loop. So if I just ran this while loop, I'm not running the for loop, just the while loop, I would see that const is going to be 1.001. Barely made it, but it's over 1. Every time we go through the while loop, it checks this condition. If const is greater than 1, break out of the function. That's exactly what happened. You know, just to prove it's not a fluke, we can do it again. Const over 1, so we break out of the loop. If we didn't have this break line, obviously this thing would go forever. If it was a condition that was impossible to achieve, it would also go forever. But that's kind of how what we can use to get out of the while loop. So once we run the while loop, once we've generated a random normal greater than the value 1, then we do the same thing from before, where we add on to the next value. So the ith value of x is going to be the I minus 1 value plus this constant value, which is greater than 1. And this is useful, right? If you're like, you probably faced a lot of questions in 110 or similar classes where it's like conditioning on a normal that is greater than 1 or greater than 0, what's the new distribution, blah, blah, blah. And, this is a useful way to kind of do that, because this while loop forces us to have a value that's in a certain area. So if I run this whole piece of code, it will run, and I print out x, and you're going to see x is just this, increasing in size, because we're adding onto it each time, and we're adding on a value that's going to be greater than or equal to 1. So, or I guess just greater than 1. So if I did this diff function, tells me the difference between each value. This is how much each value increases, and you can see that it increases by over 1 each time, because that's exactly what we told us to do. So yeah. Cool. So are there any questions on what we just did? If not, we will take a quick break. But do we have any questions on this stuff? Awesome. Cool. So if there are no questions, let's just take a 5-minute break, look at something other than your screen for 5 minutes, and then we will come back and talk about simulations. So back to R. We talked about the basics of R, functions, and loops. That honestly, what we've learned, parts of it may seem simple, but you can build upon those blocks to get very complicated, very useful pieces of code. Just kind of like in 110, where you start chapter 1 counting, and it's like, oh, this is so simple, and it can get very complicated. You can do the same thing with the building blocks that we've learned. So we're going to attempt to do something like that with this next part, which is a simulation. So R is really awesome because it can simulate stuff. It can simulate answers we don't know how to solve analytically, and it can kind of get us results that we wouldn't be able to just do with pen and paper. It's nice because we can simulate experiments instead of going out into the world and just like, seeing what happens if we did something over and over. We can run it in our computer, a bunch of times. And then we can also double check our analytical results. Like if you're, doing a 110 or whatever, 111 p set, and it's like, I think this answer is right, but I'm not sure, it has something to do with the normal distribution and some sort of probability associated with it. You can go to R, simulate it 1,000,000 times, and see if what you get matches your answer. So it's just a very, very useful tool. I use it all the time, for that. So we're going to just do an example of a simulation here. Specifically, we're going to do a Monty Hall, Monty. I always mix up Monty Hall and Monty Python. So we're going to do a Monty Hall simulation. Hopefully everyone is familiar with it. I'll give like a brief overview of the problem, but I'm sure you guys have heard it ad nauseum at this point. So that's kind of why I picked it. So the first line here, the first thing that's important for simulations is setting the seed. So when we're doing a simulation, we're essentially randomly generating a bunch of numbers. The issue is the computer is never truly random. And I don't know what implications that has for determinism versus free will, but at least in the computer is never just like doing totally random numbers. It has a very complicated algorithm, computation sort of thing that allows it to generate seemingly random numbers that, work according to some predefined pattern, like a normal distribution. So when you set a seed, you're basically telling the computer to start that algorithm in a specific place and then generate the random numbers from there. That's really useful because you can replicate random results a bunch of times. So instead of running something and getting a different answer each time, if you want to share the code, you want to show someone else what you're getting, you set the seed, they'll get the same thing that you do. So in this example, I'm going to set the seed. Let me clear my console here. I'm going to set the seed at 111. So the function is called set.seed. It's in base R, and you just enter a number. It tells it kind of where to start. I chose 111 because the course name. And if I generate a random normal value, I'm going to get 0.235. Generate another random normal, I'm going to get negative 0.3307. So obviously, when I did the second R norm, I'm not expecting to get the same value, right? It's a very, to like 7 significant digits, like there's no chance it's going to be the same value as the one I did before. The cool thing is if I set the seed again, so if I set the seed of 1, 1, 1, and I generate a new random normal, voila, I get the same value as before, because I set the seed in both cases. I'm telling the computer to start. It's a random algorithm from a specific place. It's a random algorithm from a specific place. I'll get the same result. What would happen if I ran rnorm a second time? So let's say, what's going to happen if I hit enter? What am I going to get?
You should get.
So if I run it again, go ahead.
I was just going to say you should get negative 0.3307.
Exactly. I'm going to get this value because, again, we're starting from the same place, and it's just going to spit out the same kind of like random pathway. So very useful for sharing your code, seeing the answer over and over. Okay, so that's setting the seed. We're going to set the seed again. And then we're going to initialize NSIMS, which just stands for number of simulations. That's an old, it's funny because I learned like that there's different naming conventions for everything. And I've learned that from Kevin Rader when I first started taking 111, and it's stuck since. So NSIMS, we're going to say 1,000 times. And now we're going to be doing the Monty Hall problem. Hopefully everyone's familiar with Monty Hall problem. If not, I'll give a very quick overview. There was a real game show. I don't know if it was called the Monty Hall game show, but the contestant sees 3 doors, doors 1, 2, and 3, picks a door. We just assume usually in 110 that they pick door 1 for concreteness. So you pick door 1. Behind 2 of the doors, there are goats. Goats basically meaning no prize. Behind one of the door, there's a car. Obviously, you want to win the car. You might want to win the goat, but in this case, you want to win the car. The goats and cars are randomly placed, and you do not know where the goats and cars are. However, the game show host, Monty Hall, does know where the car is, and he knows where the goats are. So what happens is you choose door 1, Monty opens door 2, and he opens and reveals it's a goat, and he says, do you want to switch from door 1 to door 3, or do you want to stay with door 1? And Monty will never open a door to reveal the car, because that would just end the game right there. He'd be like, oh, I opened the car, you lost. He's always going to open the goat. He knows where the car is, so he will always open the goat. And obviously the age-old question is, do you stay, do you switch? Of course, everyone's like, oh, it should matter, it's 50-50. And as I'm sure you guys have seen ad nauseum, you have a 1/3 chance of winning if you stay on door 1, and you have a 2/3 chance of winning if you switch to door 3, or to the door that Monty didn't open. So this obviously is a problem that even I still have a lot of trouble. I know how it works. I've done the proofs like many ways. I have trouble with the intuition. This is a problem where if you solve it, you're not sure if it's right. You can just go to your computer, play the game 1,000 times, and see what happens if you switch and what happens if you stay. You can simulate the results, which is exactly what we're going to do here. So I'm going to start out by defining basically these vectors that are going to count if I win from switching and if I win from staying. Okay, so I have this switch win. I'm assigning, and this like little double assignment that allows you to save space. So it's basically saying, the rightmost thing, which is, we've seen this before, repeating zeros 1,000 times and sims times. I'm going to assign that to the vector stay underscore win and the vector stay switch underscore win. So if I run that code, I'm just, one sec. If I run that code, both switch win and stay win are vectors of length 1,000. I didn't want to print out all 1,000, so I just used this head function. It just shows you the first 6 values in the vector. So those are going to keep track if we win from switching and if we win from staying. I'm going to enter the value of 1 if we win from either of those. And then I'm going to define a function because I know I'm going to be doing this simulation a bunch of times, and I know I'm going to have to use this code a bunch of times. So I'm just going to define a function to kind of make it easy, and I can just call the function instead of doing the code over and over. So in this case, again, fun underscore means it's a function, not a constant, not a number. Fun underscore Monty. This is going to represent Monty. This is going to represent randomly putting the car behind one of the doors. Okay, so before the game starts, we put the car behind one of the doors. This sample function just allows us to sample. It's from base R, it's defined already. Allows us to sample a value 1, 2, or 3, and it allows us to pick one of the values. So these 1, 2, or 3 represent the doors, and we're going to pick the door that has the car. So if I define fun Monty in my console, and I run it. And notice that this is an interesting function. It takes no inputs. These parentheses take no input, so I just run it, and it doesn't need any arguments. It just spits out a value. So if I run fun Monty with no argument, I get 2. So in this case, it's saying we put the car behind door 2. Can run it again and get door 3, door 2, door 2, door 2s, and there's door 1. So we're going to use that code in our loop. And now we're going to actually start our loop. We're going to kick it off. So we're going through our loop for and iterate through with the variable I. You can change I, you can change it to J, you can change it to K, you can change it to banana, but I is just like a very common thing to use. You're going to go from 1 to n sims, which is 1,000. So you're going to iterate I from 1, 2, 3 all the way up to 1,000. And again, our code is going to be within these brackets. And in this case, we have much more code in our for loop relative to before, where it was just like one line. Okay, so basically each iteration is going to represent playing the game a single time. We're going to do it 1,000 times. So let's kick it off. No, I did this wrong. One sec, let me make sure this is right. Okay, I think I said goat door instead of car door, so I'm gonna replace all those. Okay, awesome. So, okay, let's put the car behind one of the doors. That's the first thing we do. So let's say the car is behind door 2, right? We're assuming that we pick door 1. So if the car is behind door 2, then we pick door 1 and Monty has to open door 3, right? Because we picked door 1, he can either open door 2 or 3, but door 2 has the car, he's gonna open door 3 and reveal the goat. So in this case, right, we're gonna draw the car door and then we're gonna determine what door Monty opens, right? We have 3 different cases, if the car is behind door 1 or if the car is behind door 2 and door 3. As we just kind of mentioned, if the car is behind door 1, so if car door is equal to 1, Monty randomly picks a door between 2 and 3. So he samples one of the doors 2 or 3. Because both of those are goats, he can open kind of either one in the problem states, he'll open them equally. So if the car is behind door 1, he opens 2 or 3 equally. It's a little bit easier if the car is behind door 2. If the car is behind door 2, we have to open door 3. Monty has to open door 3 because we picked door 1, the car's behind 2, he has to show the goat behind door 3, so we just assign 3 as Monty door. And if the car is behind door 3, Monty has to pick door 2 for the same reason. Like the car is behind door 3, we pick door 1, he has to open door 2 to reveal the goat. So the Monty door is number 2. Awesome. So we define the car door, what door the car is behind, what door that Monty opens, and let's see that what our like switch and stay doors are. Okay. So we already know that if we're staying behind door 1, right? So we can just define that as door 1 because we're going to stay. We're not switching. If we are switching and Monty opened door 2, so this is saying Monty door is door 2. He opened door 2. We're going to switch to door 3, which is the closed door. Okay, so the switching door is door 3. And if Monty opened door 3, then we obviously can switch to 2. Monty, the switch door is 2. So all these like little if statements. So that's just a lot of like if statements just to determine what door the car is behind, what door Monty opens, what door we stay to, going to be door 1, and what door we switch to, door 2 or 3. And once we've done all that, we can finally check if we actually won. Okay, so again, we know that the car is behind whatever, we save it in car door. If our stay door, which equals 1, if we stayed and the car door is equal to 1, right, if these two things are equal, then we mark this iteration, the ith iteration of stay win as 1, which means a success. So 1 is a success, 0 is a failure. If we stayed and the car is behind door 1, then we win. If our switch door, if the door we switch to is the same as the car door, then the switch win, the ith value of switch win is equal to 1. So we count that as a win for switching. Okay. So I know that was just like a lot of me rambling. Does anyone have questions on this portion of kind of what we're doing? Awesome, no questions. So let's just run it and kind of see what happens. I'm going to run this code. It just played the game 1,000 times, super fast, really nice. If we look at the first values, the first 10 values, switch win, we see that these ones indicate that we won, these zeros indicate that we lost. And it can tell you that it kind of works. Like what we, you know, this is how we would expect the output to look like. Maybe not the frequency, but this is how we'd expect the output to look like. And what's really cool is we can use this mean function to kind of determine, the mean function is taking the average to kind of determine how many of these values are 1 and how many are 0. Because if half the values are 1, then the mean is going to be 0.5. So if I do mean of switch and mean of stay, oh my goodness, it exactly corroborates what we think. If we switch, we win 67, 2/3% of the time. If we stay, we win 33% of the time, so 1/3 of the time. So super cool, basically allows us to, you know, check our intuition, see if things work, and obviously in this case, the rules of probability hold, so kind of the result works. You're probably going to be doing a lot of simulations like these in your work, and it's important to remember using for loops, using functions, using if statements can really help you to do complicated stuff. So does anyone have any questions on this, what we did? Awesome. Awesome. Well, if that's that for that section, we can move kind of to our last section here, which is just plotting. So there's a lot of different plotting, ways to do plotting, ways to do visuals in R. We're going to be working with just the base. So just like kind of the most basic, you'll still get great graphs out of R. There's one really cool package called ggplot2. Maybe a lot of you are familiar with it. It'll make some really beautiful graphics, but it's a little bit more complicated to use. In the 171 link I sent, I have a section on how to do ggplot. So if you're interested in that, check it out. It's not necessary because this will get the job done, but you can definitely make way prettier graphs if you are interested in that. Let's kick off this section by actually generating some data. Here I'm going to define n as 100, so I have 100 values. I'm going to define x as just a vector all the way up from 1 to n. So let me just clear up my console here. So x is going from 1 to 100, nothing crazy about that. And y is going to be a repeated vector of 100 zeros. So y is just 0 100 times. Okay, and I'm going to do this for loop. By now, hopefully we are comfortable with this. For I in 2 to 100, we're just going to generate the ith value is the I minus 1th value plus a random normal. So, you know, in this case, we're just adding a random normal on each time. You know, we've seen this a couple of times now. If I run this, I'm going to see that y, you know, is this kind of drifting around value, adding random normals, whatever. So obviously, we just kind of generated those values. We generated x and y. It would be great if we could plot it and actually see what's going on. And fortunately, you can using a very simple base R package intuitively called plot. So we have two vectors x. We have vector x and we have the vector y. And if we just use plot xy, if I run this, oops, that's not what we want. If I run this line, we're going to get this awesome plot. And you see that my the bottom right automatically jumps up because R is like, look, I made this plot for you, check it out. And this is great. We have, you know, I can drag it around to make it bigger or smaller or wider. I can, if I click this export, I can copy it to the clipboard, copy the plot, put it anywhere I want. And basically, it's, again, we have the x values going from 0 to 100 and the y values kind of on the y-axis. So that's awesome. You know, we can, very easy to make a plot in R, very simple. And I'll show you a couple of ways to really spice things up. So here I have dots. Dots are probably not the best way to look at the specific data. So if I go back into my script editor, line 18 here, it's the same function, but the argument type, I use L, and L is line instead of points. So if I run this line, I'm going to see this beautiful plot with line instead of points. So for x and y. So this is a little bit nicer to look at, I think. Plot could still use some spicing up. So let's go to line 21, where we can add some more arguments. So we plot x and y. We're using a line. We're going to use, we're going to define the line type. So this LTY means line type. We're going to define it as 2, which I believe is a dashed line. You can Google like different R line types for all the different types you can get. We're going to set the color. So col equals red. And we're going to set the LWD, which is the line width, to 3. So we're going to run this. And look at that, beautiful. We get a nice dashed line. It's, you know, it might be ugly, but it shows that we can do a lot of different things. And again, if you just type question mark plot, you're going to see, and click on this, you're going to see all the different arguments that you can use. So P for points, L for lines, titles, you know, all different stuff that you can like use to customize your different plots. We'll do just that now by adding some titles. So to the same plot, we're going to add X lab, which is the X label, Y lab, which is the Y label, and main, which is the main title of the plot. And you can see we've got our labels here. So X value, Y value, and we have nice plot on the main thing. Cool. And then kind of the last thing with plotting in base R is that it kind of draws a picture, and then you can draw pictures on top of it. So, you know, if I run this line, if I run the plot, it's gonna draw a nice picture. You can, if you haven't run anything else and you haven't like made a new plot, you can add, run new functions to add on top of it. So if I run this function AB line, this is gonna add a line where the H, the horizontal intercept, is 0. It's gonna add a flat line, and the line is gonna be black. So if I just run this line, I'm gonna get this nice horizontal line here. And if I use this function lines, it's, this function lines is basically adding to this plot. The X values are going to be X plus 6, and it's going to be the same Y value. So, and the color is going to be blue. So if I run that, you're going to see that the red lines are kind of just shifted to the right, X plus 6. So that's kind of why you see those values. And you can continue drawing on this, like with more lines, AB lines, or running extra functions. As soon as you make a new plot, you're going to get a totally new picture as soon as you run plot again. But in the meantime, you can run all sorts of things to kind of pretty up the graphs. Awesome.